Okay, take two. All right, so our standard error, S of E, is the square root of the quotient of the summation of y squared minus B times the summation of y minus M times the summation of xy, all divided by n minus 2. The nice thing is we've already found all of that, which is why we're going to use this formula instead of the other one. Okay, so if we use our regression equation, and we're going to use the one that your calculator actually found, and I'm not still didn't figure out what we did wrong yesterday. Forgot to go back and look. So the regression equation for the number of years alumni have been out of school and their linear annual contributions is y hat equals negative 0.380x plus 12.877. Find the standard error of the estimate. So to use our formula, we need to know these values that we already found. So the summation of y squared equals 587.05. The summation of y is 56.7, and the summation of x times y is 435.6. Okay, remember, this is our m, this is our b, and then the other thing we need to know is our n, which is 7. And then we're going to plug in. So our formula, S of E equals the square root of 587.05 minus our value for B, 12.877 times 56.7 minus our M, which is our negative 0.38 times 435.6. And that's all over 7 minus 2. And then it's just calculator. Okay. Okay, so depending what kind of calculator you have, when you're doing the square root, if you have an older calculator, make sure that you are putting parentheses around your numerator, parentheses around your denominator. Okay, if you have a newer calculator, just leave it the way it is. Okay. Do your fraction. How about we do square root first? And then do your fraction. So we have 587.05 minus 12.877 times 56.7 minus negative 0.380 times 435.6 all over 5. We're always going to round to how many decimal places? 3. So S of E, 2.119. Questions with that?
So in what situation do you use this formula?
This is what we're going to use to find our prediction interval.
What is only regressing?
We still have to have that significant linear correlation, which is what we tested with the critical values. Okay, so once we do that, then we can keep going with all of this. Okay. So what we're going to be using it for is these prediction intervals. So two variables have a bivariate normal distribution. If for any fixed values of x, the corresponding values of y are normally distributed, and for any fixed values of y, corresponding values of x are normally distributed. Because regression equations are determined using sample data, because x and y are assumed to have bivariate normal distribution, you can then construct a prediction interval for the true value of y. So remember, we're still looking at samples. So we're making predictions for the population. Okay. So to construct that prediction interval, we're going to use a t-distribution And the thing that's different is we're going to be using n minus 2 degrees of freedom instead of n minus 1. And the best way I can explain that is because we're having to use two variables, x and y. Okay? Because of those ordered pairs and bivariate data, it changes it to be 2 instead of the 1. Okay? So given a linear regression equation, y hat equals mx plus b, and x sub 0, okay, that's going to be a given x value. A C prediction interval for y is y hat minus e, which is less than y, which is less than y hat plus e. Where, we're going to have a new formula, e equals, I'm actually going to write it down here. There's a little bit more room. So we have our critical value, TC, which is going to come from table 5, times S sub E, which is what we just found, times the square root of 1 plus 1 over n plus n times x sub 0 minus x bar squared, or quantity squared, divided by n times the summation of x squared minus the summation of x, quantity squared. Okay, so again, funky formula, but all things we've already found or will be given to us. This is where the point estimate is y hat and the margin of error is e. Okay, the probability of the prediction interval contains y is c. So here are your steps. We're going to go through these in this last example. Okay. Okay, identify n and find the degrees of freedom n minus 2. Use the regression line in the given value of x to find the point estimate. Use table 5 to find your critical value. Find your S sub E, which is the formula we just wrote earlier. Then find your margin of error, E, and then find your confidence interval. All right, so we know our n is still 7. Which means our degrees of freedom is what? 5. Okay. We know our y hat equals, let's scroll back, negative 0.380 x plus 12.877. That was the equation we found yesterday. And then I'm going to go ahead and rewrite our S sub E that we just found was 2.119. All right, so we just did step 1. So step 2, use the regression line for the given value of x. So we're wanting to create a 95% prediction interval for the annual contribution in thousands of dollars when the number of years at a school has been 5. 5 is our x sub 0. Okay, so our y hat, we're going to plug that in. So negative 0.38 times 5 plus 12.877. And we get 10.977. So when we get to the very end of this problem, that's what we're going to be adding and subtracting our margin of error. Okay. So now using table 5, we're going to use our degrees of freedom 5 and our confidence C equals 0.95 to find our critical value, which would be what? So degrees of freedom 5 and a C of 0.95. 2.571. And now we need to find our margin of error E by plugging into this formula, which I'm going to copy and paste it down here. That way we can see it and plug it in at the same time. So E equals the critical value, 2.571, times our standard error, 2.119, times the square root of 1 plus 1/7 plus, okay, our n is 7 times the quantity. So our x sub 0, what was our x value that we plugged in? 5. Minus our x bar, we found that earlier, is 12.571. We found that yesterday. And then keep plugging in. So we have 7 times the summation of x squared is 1,836 minus the summation of x quantity squared is our 7,744. And then it's just a calculator game. Here's what I recommend you do. Don't worry about what's on the outside yet. Find that square root first. So we have the square root of 1 plus 1/7 plus this fraction, okay? If you have an older calculator, you're going to need parentheses. And you're actually going to need to put parentheses around this 1/7 as well. And I would put parentheses around the whole fraction. Okay. If you have a newer calculator, though, use that fraction button. And then once you get that radical, then multiply your answer by your critical value and your standard error. And again, round to 3 decimal places. So our value of E should equal 6.021. Okay. Okay. So we're gonna finish this up, and then if you have questions and you're typing in wrong in your calculator, I'll come around and look at them, okay? So to finish off your interval, you're gonna do your y hat minus E and your y hat plus E. So we have 10.977 minus 6.021, which is less than y, which is less than 10.977 plus the 6.021. Which gives us 4.956, which is less than y, which is less than 16.998.